Okay, let's look at this problem 2973, which was last in the bi-weekly contest 120. So the question is find number of coins to be placed in tree nodes. In this question, we are given a graph, and this graph is in the form of tree, which basically means there is no cycle in the graph. And then for each node, there we are given a cost. And what we need to find is what we are asked in this question is to place some coins on each of the node. And how do you determine what will be the value of the coin? That is through two ways. So if we stand at a node, let's say you stand at 0, and then you check what is the size of the subtree. If the subtree is of size less than 3, then the placed coin will be of value 1. Else, if it is greater than equal to 3, then the cost will be equal to the maximum product of 3 nodes cost. So whatever is the maximum product you get after multiplying 3 nodes cost, that will be the value of coin which you will place at that node. So now, how do you find the maximum product? One basic thought which comes to mind is just to multiply the three largest number to get the maximum product. But another way of looking at it is to multiply two smallest and one largest number also. Why so? Because when let's say these two number are very large in quantity, and when you multiply this become positive. So two negative become positive, and then you multiply the largest positive number, that in this case should be 38. That could be one of the possible answers. And it is also given whenever if in all cases the maximum product is negative, then you can just put it 0. So we have to take max at each node. We have to find three largest, two smallest, and one largest. I means product of three largest, product of two smallest and one largest, and 0. So we have to find the maximum between these three at each node. Okay. So stand at a node. Find also keep in mind that uh, the node at which you are standing is also in the subtree. So 37 will also be the value which will be included for determining the maximum product. So stand at a node, find three largest, two smallest, and one largest, and then find the maximum product if the size of the subtree is greater than 3. Okay, now let's look at the case here. So let's say you are standing at this node u, and now you want three largest and two smallest nodes in this subtree. So how can we do that? That node will have, let's say, three subtrees, and each subtree will again have three large and two small values, given there are enough number of nodes. So what we can do is we can do a DFS traversal, and at each DFS traversal we return from each subtree three largest and two smallest value to the parent node, and in that parent node we can take all of the values, let's say, in a heap, and then we can find three largest and two smallest for that particular node u. So take three largest and two smallest from each subtree, add it in a heap, so that you can find three largest and two smallest for that current node. Okay, now three edge case will arise here. Let's say when you have one um, in this subtree there is only one node. So what we have to do is, we are given that if there is less than one node, so when you stand at this node, you have number of node is equal to 1, so this subtree will have one node. So in that case you have to place coin of value 1 here. And so what we will do is we will place u equal to 1 and return this value, cost of this value, to our parent node, so that it can uh, uh, use it to calculate the three largest and two smallest value. Similarly, if there are two nodes here, then also you have to uh, put the coin of value 1, so placed u will be 1, and then you can return these two, both of these values, to the parent node, for consideration of three largest and two smallest. And we will also have to check three, for value of 3, even though we are given that for 3 we will check three largest, uh, for for subtree having nodes greater than equal to 3, we have to take the maximum product uh, of the three largest nodes. But when you take the case of, let's say, this subtree under this parent, we will find three largest and two smallest, for, as we are given before. But let's say value of this is 1 2 3, then three largest will be 1 2 3, and two smallest, three largest will be 3 2 1, and two smallest will be 1 2. Now you see that these 1 2 are common in these both, and and these are repeating. So when you return this all value in an array to this, there will be multiple entries for this same value. So instead of returning all the three largest and two smallest, you just return all the three values, that is 1 2 and 3, in this manner to the uh, to the current node, so that there is no repetition. So that's all that we have to, for each subtree, we have to return three largest and two smallest, so that we can use this formula, that is maximum of L1 L2 L3, or S1 into S2 into L1 and 0, for finding the cost of that particular node. Okay, you might think that what happens when uh, the number of nodes in this subtree is 4. So let's say the value is 1 2 3 and 4, and this is the parent node. So let's take this example, and we will use this formula for this, and also return uh, 3s and 2s, that is L1 L2 L3 and S1 S2, to the parent node. So let's do that. uh, if we return all these value L1 L2 L3, which will be L1 will be 4, L2 will be 3, and L3 will be 1, S1 will be smallest is 1, and S2 is 2. So and the value of parent is, let's say, 5. So all these will form a subtree, and these all values will be added to the heaps, which is max heap and min heap. So the values will look like this. Now, for if we have all the values of this node, now we have to find three largest and two smallest. So three largest will be 5 4 3, and two smallest will be 1 and 2. So what do you see here is, if you would have taken max heap, maximum 3 would have been 5 4 3 1, and minimum 2 will be 1 and 2. Sorry, 2 here. So you see 2 is repeating here, but in this case, when you take minimum, you are only looking up till first two value. You won't look beyond that. So these two will not create a problem here. So if you're not understanding this, look at the code and try thinking about why we are not taking an edge case for 4 number of nodes. Also, when you include this in the parent, all these become a 5. Um, it will become a heap of size 5, so it won't create problem in taking three largest and two smallest. If you don't understand this, then you can also skip this part. It's not a problem. um, so basically, at every node, ask each subtree to give three largest and two smallest, and then form a array so that you can find the value of coin by using this formula. So it's safe now to move on to code. So let's see how to write this. Get a variable n which will store the number of nodes in the graph. So it's given that it should be of edges.size plus 1 because uh, there are edges of length n minus 1. So we can use n edges.size plus 1 to get the value of n. And let's create edges, say edges of this. So that's vector int adj n. Now for each of the edge, let's add it to the list. adj e0 dot push and e1 and adj e1 dot push e. Okay, so this is undirected graph because here we aren't given any direction of it. So it can be both ways. It depends upon from where we are starting. Now let's create a vector named as placed. This will store the value of coins which are placed at that node. So it should be of dimension n, and let's initialize it with 0. Now we'll call a DFS here, and then after that call we can return placed. So after DFS we should get the value of all the value of coins here. So let's create a DFS. So DFS, what should be the return value of DFS? DFS, it should be of vector because we are going to return three largest and two smallest in this for each of these nodes. So what are we going to pass in DFS? We will pass the current node. Also, we have to pass the parent node because if you don't pass check, so when you stand at a node and look for the nodes which you have to visit, you will not visit the parent node because then it will fall in a infinite loop. So you have to check if the node you're visiting isn't already visited parent node. So that's that. Then after that, our list. And then finally our placed vector of dimension long line. Okay. So for each node we have to make two priority queue. One should be max heap. So let's give it name max heap. And other should be min heap. So how do you define min heap? You basically write int the parent and greater. Now since we have defined these two heaps, what should be the first step is to insert the current cost. It means the cost of the node at which you are standing. So max heap dot push cost. Oh, we have to also add cost here. So let's add cost. So cost u, and also add it to min heap, because it can be both among the largest or among the smallest. Now let's iterate to all its children. So auto let's call it uh, child, and then adj u. So when if this child equal to p, then we can continue it and not proceed further, because as mentioned, we need not to visit the parent node. And after that, let's store the value of 3 largest and 2 smallest for its children in a temporary vector of long, and then call the TFS here. The parent name should be child and parent is u. Agency is agency only, and then placed should be placed, and then cost. Okay. Since we have that stored in a temporary vector, we have to then iterate it to get all the values of it. I less than equal to temp.size, and then for each of the values in the temp, we have to add it in the max if and min if. So basically, same thing here. Temp I and temp I. Also, let's create a variable int nodes equal to 1. We will initialize 1 because we will definitely have one node because we are standing at that node, and after every node we get from the temp, we have to increase the value of nodes by 1. So that is the number of nodes in that particular subtree. So this variable will store the number of nodes in that subtree, subtree u. Okay. After this, we have created our priority queues of both maxip and minip so that we can get the 3 largest and 2 smallest. Now, let's first take the smallest first. It can be in any order, but let's take the smallest first. So long, let's name it S1, and that will be equal to min heap dot top. And after you have extracted that, we can pop this. Now, let's say if our subtree has nodes equal to 1, then what we can do, we can assign the value placed u to be 1, and then we can return a vector which will have its cost. So whenever we are standing at, let's say, this node, and we have value of nodes is equal to 1, and so we have to place the so let you see that the output, which is the cost of the value which is placed at that point, should be 1. So here also we have added 1, and we will return the cost of it, so cost is 2, to the parent node to check if it is among the 3 largest and 2 smallest. Okay, that's that. And then okay, okay, now let's say we have extracted the second smallest, and now we will check if the node is equal to 2. So when there are 2 nodes in that particular subtree, Then also we have to place value 1 there, and then return um, both the cost of the two nodes. So basically S1 and S2 to the parent. Then again we will extract the third variable now. So what we are extracting now will be the L1, which is the largest now. So this should be max heap and this should be max heap. So we have extracted two smallest now. Now we are going to extract largest available in that particular subtree. So that should be L1, and then we will check for the case when nodes equal to 3. In that case, we will check what is the largest product we can get. So that should be equal to maximum of S1 into S2 into S3 L1. So it doesn't matter what is S1, S2, S3 here, L1 here, because in nodes 3 you will have S1, S2, L1 will contain all the nodes, all the costs which are present in that particular subtree, because it has 3 nodes only. So you will just check if this value is positive, then return that value, else it is negative, return 0. Uh, so you have that now. So what should be the return value here in the vector? So we will return all the values in the node in that particular subtree. So S1, S2, and L1. Look at this part. It doesn't mean here it doesn't mean anything here, because here S1, S2, L1 is just all the cost which is present in that subtree if it has 3 nodes. Now, these variable names will be useful when we have nodes of value greater than or equal to 5, or even in case of 4. So let's extract the last two elements, which is L2 and L3. The operations will be same. Now, what should be the value at that node which we should assign in place? So that is maximum of L1, L2, L3, or S1, S2, and L1, or 0. So this should rightfully assign that value of coin at that U. And then for this subtree, if it has value of node greater than 3, then we can return all our values in this way: S1, S2, L1, L2, L3. Okay. This should be it. Okay, we have to call also. So let's start by index 0. Parent is -1 here because there is no parent for 0. We will pass the list here, and then also placed and cost. Let's check this. Okay, list equal to here. Okay. Also remember this max operation. Both the values are not of same data type. This is of long and 0 is of int. So we should use long here and here also. This should be it. Let's try again. This should be also long. Okay, it got accepted. Let's try on all cases. Okay, it got accepted. Thanks for watching.